All right, so I'm very glad to be able to give this presentation on behalf of Brad Jolliffe, who couldn't be here with us this week. But basically, I'm going to give an overview of kind of the objectives behind MoonRise and hopefully lay out some of the relevant science, not just for the moon, but also science that's going to be relevant for understanding the entire solar system. If you were in the SPA and impact bombardment lunch on gosh, it was already Tuesday. It feels like a long Tuesday. We discussed at quite great lengths the importance of understanding SPA as not only for understanding an early history event on the moon, but also for tying together events across the solar system. And so we're very excited for the potential for MoonRise to be selected for further study. We'll find out later this year. And hopefully by the Survey Forum in 2024, we'll be able to start talking about some of the results from the mission. So circle July 2024 on your calendar already. So, MoonRise, the concept of SPA sample return is not new. It's been a high priority science target for a number of years now, and there are some fundamentally compelling science questions that could be addressed from sample return from SPA Basin. Most important and sort of the top first question that we would want to address is, what was the heavy bombardment history of the moon? Was there a cataclysm? How long was it? And really, by understanding the age of SPA, we can start constraining what was happening in the earliest history of not just the moon, the Earth moon, but also the inner solar system. What are the implications for early Earth and terrestrial planets? And this has been a part of a discussion that we've had now over the last few days, is understanding what was happening early on the moon, and by proximity what was happening on the Earth, and what are the implications for heavy bombardment of the Earth for the onset of complex life. And then what are the implications for early solar system dynamics? And Bill Bottke's in the room, and some of his colleagues who have sort of tackled these issues of understanding what was the triggering mechanism for leading to these bombardment histories. So why SPA? One of the discussions that we had, sort of a short discussion in the session on Tuesday was, well, is SPA the oldest basin on the moon? Well, I would advocate that even if it's not the oldest basin on the moon, where are you going to go to date something older? SPA is the largest, best defined, oldest event on the lunar surface. It's a unique location in the moon, in the Earth-Moon system, and in the solar system. It is a clearly recognizable lunar impact basin. We can tell exactly where we need to go in order to get the material that will tell us the age of that basin. The SPA event completely resurfaced a large portion of the moon, not just this massive interior area, but of course there's ejecta we anticipate that was ejected across the lunar surface and reset ages over an enormous area. This was a global event, a resurfacing event. This would have been one of those time horizons that we will have on the lunar surface. SPA anchors the lunar impact chronology and provides us with the best understanding for what was happening earliest in lunar history. So determining the age of this basin is going to be critical for interpreting the lunar impact chronology. So there's other, of course, compelling science questions. SPA as an end member case for basin forming events will give us a better understanding of the large impact basin formation processes on the moon, and then, of course, by analogy to other bodies in the solar system. By sampling this deeply seated material, either from the lower crust or even the upper mantle, we can infer processes that produced heterogeneity across the moon, and indeed maybe when a core dynamo was even active. Samples of such old material will also help us infer the part of the earliest thermal evolution of the moon. As I'll show later on, we know that there are heat-producing elements that are distributed across the interior of SPA, but by getting samples from this very unique region of the lunar crust, it will help us better interpret the entire thermal history of the lunar interior. And of course, no matter where we go certainly no matter where we go in SPA, we'll get some small fragments of lunar basalts, even if we don't land on them. And so by getting samples of far side melts, we'll also better understand the heterogeneity of far side, near side mantle. So as any good mission does, we will test very important key hypotheses. Again, by determining the age of SPA, we can place constraints on some models for the dynamics of the early solar system. There's been this very intriguing set of analyses over the last few years looking at whether or not a magmatic event could have been triggered by the formation of SPA. And so again, determining the age of SPA in relationship to some of the known samples, basalt samples that we have from the near side, that may help constrain models for the triggering of near side volcanism. And of course, then the process of forming a large basin, what occurs when you have something the size of SPA in terms of the excavation and, of course, the melting and then the differentiation of that impact melt in a unique region of the lunar crust. And all of these questions could be addressed by just a simple 1 kilogram far side sample return mission. Of course, MoonRise addresses planetary science decadal survey high priority sciences. That's why we're in the New Frontiers competition. And of course, it is also cross-cutting through many of the themes that are important within the decadal survey. So, I want to talk a little bit about how we're going to be looking at SPA and identifying where we're going to go. The samples that we get back, and again, and I'll show an example of what I mean by samples. 1 kilogram of lunar regolith is what I mean when I talk about samples. Of course, we'll get the age. Of course, we'll get bulk composition, then also mineralogy. And each of these three things integrated together will give us really a phenomenal insight to this unexplored region of the moon. So let's talk a little bit about composition and particularly the iron content. Now, SPA had been even sort of hinted at as being compositionally anomalous back in Apollo data. The lunar prospector gamma ray data obviously highlights the well-known iron enhancement within the basin interior. Not all of these enhancements in iron are associated with clearly identified mare basalts. There are certainly evidence of widespread cryptomare across portions of the interior, but then there are also areas that may not be cryptomare that have an enhancement in iron. The inference is that for most of the clearly non-volcanic materials that that the iron enhancement is associated with impact melt generated materials from the formation of SPA. So basically this provides our first sort of roadmap, to use one of Clive's favorite words, of where we want to go within SPA. We're going to aim for an area that has a high iron anomaly. Next, mineralogy. The wonderful data set from the Moon Mineralogy Mapper started to, clarify or create more confusion. I'm not confusion, but insight, and it's up to us to unravel. That's right. Thank you, Carly. But provide more insight. And I think if you go back and you read Carly's 2001 paper, we're using Clementine data to disentangle SPA. And for years, I remember that was gospel truth. Carly said it has to be true. And then we get more data and think, well, it's still true, but different. And it's truish. Funny, it doesn't look truish. Never mind. Anyway, it's Thursday morning. So Dan Moriarty has done some incredibly detailed analysis of the M-cube data. This is a map of multiple M-cube strips mosaic together, revealing subtle differences in the position of the 1 and 2 micron band depth. This specifically is a 2 micron band depth, and what he's shown in a series of papers that have been published and have just been submitted is that there's this central compositional anomaly, the South Pole-Aitken compositional anomaly, that corresponds to an area of both extended 2 micron and 1 micron band depths. This is in contrast to a surrounding annulus of a orthopyroxene-rich material, and then again surrounding that is a another easy word to say, heterogeneous and orthositic material sort of associated with the outer portion of the interior of SPA. So what we sort of use this data to sort of obviously again highlight that the center of the basin is where we want to go. We have these anomalous compositions, and when I say anomalous, I mean not surprisingly anomalous, but that they're telling us something very important about the evolution of the interior of the basin. And so we have to use this data set in particular to help refine where we think we want to go. The bottom line is that this compositional anomaly, and again, it's a compositional anomaly because it's different, not because it's strange and unusual. So don't think that a compositional anomaly is something we're afraid of. This is telling us something very important about what was happening both in the magmatic and impact melt materials within early history of SPA. So we target this SPACA as a real region of interest, and so we're going to drill down into that a little bit more. Yeah. So we also have the data from the GRAIL mission, which tells us, thankfully not surprisingly, that the crust below SPA is extraordinarily thin, including some of the thinnest crust beneath the Apollo and Poincare basins. And so we get some insight from this that the material sampled and excavated not just by SPA, but subsequently by other basins, including Poincare and Apollo, are tapping a very interesting portion of the lunar crust. And so even the few small fragments that are coming from subsequent basins, Apollo, Poincare, Schrödinger, which may be mixed within the regolith in small degrees, are going to be sampling some unique portions of the lunar crust. Just to reiterate this point of the relationship to magmatic history, as I said, there's been a number of studies recently that have highlighted this spike in magmatic activity about 4.3 billion years ago. And a simple question is, what is the role of SPA in triggering or in relationship to some of that enhancement in magmatic activity? Let's talk about selecting landing sites, and hopefully by the time the landing site workshop comes along in January of next year, SPA or MoonRise will be going on to step 2, and we'll be submitting our own targets that we'll be evaluating. We had one example landing site near the center of the basin, again tied into the compositional both iron and thorium anomalies within the interior of SPA. We exclude areas that are either clearly resurfaced by subsequent basins, so either Apollo here or Schrödinger or other subsequent impacts. We can then sort of come up with the resulting kidney bean shaped or region in central SPA that is perhaps sort of the Venn diagram mix of both close to but not on top of ejecta blankets from subsequent basins, not on top of clearly defined Mare basalts, or even crypto-Mare basalts. And that leaves us with an area around the Bose and Baba region. And I'm going to talk a little bit about how we evaluate Baba E, which is located between Baba and Stony craters. Again, we don't want to be on top of a Mare basalt, but with proximity, and there's a spot here that's about 100 kilometers from the nearest well-defined Mare basalt, which suggests that we'll at least get some fragments of volcanism. Now, using the beautiful LROC narrow-angle camera data, we get not only wonderful grayscale images of each potential landing site at upwards of 50 centimeters per pixel, but then with subsequent imaging, we can derive DEMs, oops, press the wrong button, derive DEMs of those sites, and then from that derive not only slopes, but also terrain ruggedness, which is sort of a derivation from the topography to highlight smooth, flat, boulder-free, relatively boulder-free areas that would be prime for robotic sample return sites. And so this is just one example of an error ellipse for landing, where we have a high confidence that we could land on not only a smooth, but basically non-rugged, non-rough spot. Now, what are we going to do with those samples? This is an example from the Apollo 11. This is, I believe, from the, as we discussed the other day, the infamous 10084 scoop, multiple scoops. But beautifully illustrates the diversity of material you get from the lunar regolith. The lunar regolith is our friend, and we use the regolith process to essentially ensure that we'll get not only a diversity of materials, diversity of size materials that we'll be able to throw our analytical techniques at. Just as an example, we are going to do in the initial sample analysis, basically throw in a coordinated fashion multiple geochronology, geochemistry techniques to really get immediate and quick insight into what has been returned. I'd just also highlight that, of course, we're planning on setting aside materials that will be then released for analysis by the community. So just in summary, over the last several years, and I mentioned with the M-Cube results following on the Clementine results, science themes out of recent missions have really highlighted the importance of SPA sample return. Every time we get a new data set, SPA becomes more and more beautifully unusual and such a wonderful spot for us to go. I talked a bit about the Spaka terrain and the sort of the evolution of understanding of Mafic Mound, which would be wonderful to solve, quite simply, by getting some samples from there. So our core science themes, just quickly, obviously is determine the SPA impact chronology. That's first and foremost our goal. But then from that derived understanding of how large basins modify planetary crusts, understanding the crust and mantle, and indeed down to the core, the distribution of heat-producing elements, and understanding the far side mantle, and understanding how differences in Mare basalts may be tied to global variations. Obviously, we addressed important solar system science. I'll leave that up here, and thank you, and look forward to having time in the discussion session. Appreciate it. Oh, okay.
Robin.
Hi.
Oh, please introduce yourself. I apologize.
the
Wait a
brick.
minute. Yeah, pass the brick. He's been holding it so long, I don't know.
Sorry, I'm Robin Knupp from Southwest Research. I wonder if you could comment on what you anticipate for the age distribution of your samples. Are you expecting a single date for SPA? Are you expecting a distribution of dates to reflect other
Sure.
events, perhaps?
So yeah, I mean, whatever I anticipate will be proven wrong, I'm sure, because that's just how I am. But I anticipate, and if I go back, there was a figure, and again, it's a totally different data set, but, okay. So, you know, this is distribution of uranium lead ages from lunar zircon grains from multiple landing sites, but it shows multiple ages from obviously diverse places. What we anticipate, and I say we, work that Barb Cohen and I have been doing, looking at the regolith dynamics of what's going to be introduced. We anticipate multiple ages that we'll have to unravel. Some of the ejecta modeling that I've done has suggested that the regolith at an interior site such as the one I highlighted here will be dominated by SPA-derived material, but will have contributions from surrounding impact craters, whether it's a large basin or a smaller one like Baba or Bose. And so I anticipate we'll get a sort of age distribution like this, and it'll be us to interpret not just that, okay, well, there's SPA, oldest event, most dominant age in the samples, but that will have these smaller spikes. And that's where some of the unraveling will have to go. So I fully anticipate that we'll get a broad spectrum of ages from different materials. And it's up to the excellent geology that we'll get to sort of apply to these samples to unravel what the other bumps and squiggles are telling us.
I would just add to that, too. I think that one of the things that we have going here that we didn't have necessarily on Apollo is the extremely high-resolution images that allow us to retroactively put things back into context, too, at all scales, from meters to kilometers. We landed Apollo 15 with 20-meter resolution images, if you can imagine that. I mean, okay, there were people to guide the lander, but still, okay. And it's just amazing what we can do with these new data and reconstructing these things, I think. Okay, thank you very much. Let me move on to the next point here. I'm going to ask Clive Neal to come up. Basically, Larry Taylor, as Clive mentioned earlier, is in the hospital. He's get an update from Clive here, hopefully. And secondly, we're going to try to dedicate this